Okay, this is lesson 65, and we're going to talk about radicals and trig equations, and also just a trig equation where some of the solutions don't actually work in the original equation. So we have to sometimes check because we're not always sure, especially if we're dealing with, things that might have negatives under the square root or things that might have zeros in the denominator. We just have to always be careful that any solution we get for any kind of equation is not going to cause those two big problems. Zeros in the denominator are unacceptable. Negative numbers under the square root sign are unacceptable when we're solving equations that are supposed to have solutions in the real numbers. So first of all, sometimes we'll have to square both sides of a trig equation, just like we have to do sometimes with other kinds of equations. In this case, we must always check our answers to make sure that they actually work in the original equation, since extra solutions are often created when we square both sides of an equation. And we've talked about this before. Whenever you square both sides of an equation, the squared equation may have solutions that the original equation didn't have. So you have to always go back and check your solutions in the original equation from back before you squared it. All right, so we want to solve sine x minus the square root of 1 minus sine squared x equals 0, given that x is between 0 and 360. So we've got sine x is equal to 1 square root of 1 minus sine squared x. We just added that on both sides. Now we're going to square both sides. We'll have sine squared x equals 1 minus sine squared x. And then we are going to add sine squared x on both sides. So we'll have 2 sine squared x equals 1. Divide by 2 on both sides, and we'll get sine squared x equals 1/2. And then we have to take the square root on both sides so that we can have sine x equals 1 over the square root of 2. And then we're going to need to use inverse sine to figure out what those angles are. What angles have a sine of 1 over the square root of 2? And we know that's all the angles that are 45 degrees. So 45, 135, 225, and 315. Those are all the angles between 0 and 360 that would have a sine of 1 over the square root of 2. Now, if we go back and check 45, for example, in the original problem, we would have sine 45 minus the square root of 1 minus sine squared 45. And so that would be 1 over the square root of 2 minus the square root of 1 minus 1 over the square root of 2 squared, which is going to be 1 over the square root of 2 minus 1 over the square root of 2, which will be 0. And that is true. That works. That actually is the solution of the equation. So that worked. 45 degrees worked. And it just so happens that if we did go through it, we would find out the 135 also works. So 45 and 135 do work in the original equation, and so those are solutions. But if we try 225, what's going to happen? So sine 225 minus the square root of 1 minus sine squared 225. That's going to be negative 1 over the square root of 2 minus the square root of 1 minus negative 1 over the square root of 2 squared. And so we're going to have negative 1 over the square root of 2 minus the square root of 1 minus 1/2. So this time we're going to have negative 1 over the square root of 2 minus 1 over the square root of 2, which does not equal 0. So what's happening here is that in the quadrants where sine is negative, 225 and 315, this doesn't work because it will give us a negative and then minus a positive. So it's going to give us a negative answer. It's not going to give us 0. So always check when you square both sides of an equation. You have to check your solutions in the original equation to make sure they work. So 225 and 315 do not work. They are not solutions. All right, so here's another one. We've got tangent x minus square root of 3 times the quantity sine x plus 1 equals 0, given that 0 is less than or equal to x is less than 2 pi. So here we have two factors that multiply together to give us 0, which means one of them has to be 0. So either tangent x minus square root of 3 is 0, and if that's true, that means that tangent x is equal to the square root of 3, and that happens when x is pi over 3 and 4 pi over 3. Now, if we look at sine x plus 1 being 0, that means sine x is going to have to be negative 1, which means that x would be 3 pi over 2. So if we check these answers in the original equation, tangent pi over 3 minus the square root of 3 times sine pi over 3 plus 1 is equal to the square root of 3 minus square root of 3 times the square root of 3 over 2 plus 1, and so that is 0. That's fine. If we try both of those, we're going to get the same thing. They both work. However, if we put 3 pi over 2 in there for our angle, there's a problem because tangent 3 pi over 2 is undefined because 3 pi over 2 is 270 degrees. So down here, and remember that tangent theta is equal to y over x. So this point here is 0, -1. The x is 0. And so that tangent does not exist at 270 degrees. So because you can't put 3 pi over 2 into the original equation for x, then it cannot be a solution. Even though it works with the sine x part, it doesn't work with the tangent x part. The tangent x part would be undefined, and so it doesn't equal 0. You just can't put it in there. You can't take the tangent of 3 pi over 2. So that is not a solution. Okay, so we're talking about how to graph the logarithmic function. Remember, the exponential function and the logarithmic function are inverse functions. That means that the domain of the exponential function is the range of the log function, and the range of the exponential function is the domain of the log function. So we will go ahead and graph the exponential function first. So for the exponential function, if I put in 0 for x, I have 2 to the 0, which is 1 for y. So the point 0, 1 is on this graph. If I put in 1 for x, I get 2 to the 1, which is 2 for y. So the point 1, 2 is on this graph. If I put in 2 for x, I get 2 squared, which is 4 for y. So the point 2, 4 is on this graph. If I put in 3 for x, I get 2 cubed, which is 8 for y. So the point 3, 8 is on this function. If I put in a negative number for x, I'll get 2 to the -1, so that'll be 1/2. So the point -1, 1/2. So that's the exponential function. We've already graphed that before. That's what it looks like. Now, let's look at what the logarithmic function looks like. So if we have y equals log base 2 of x, if we rewrite this in exponential form, we would have base to the power equals the number. So it looks exactly like the exponential function, except it is x equals 2 to the y instead of y equals 2 to the x. So as we expected, the domain and range are switched. So now if I put in 0 for y, I'll have 2 to the 0. I'll get 1 for x. So on this function, instead of the 0.01, we have the 0.10. If I put in 1 for y, 2 to the 1 is 2, so I get 2 for x. So this time the 0.21 is on the graph. If I put in 2 for y, 2 squared is 4, so I'm going to get 4 for x this time. So 4, 2 is on the graph. If I put in 3 for y, 2 cubed is 8. Now the 8 and the 3 are switched from where they were before, so I have 8, 3 on the graph. And then if I put in -1 for y, that's going to be 2 to the -1, which is 1/2. And so the point 1/2, -1 is on this graph. So you can see that it looks exactly like the exponential function, but it is reflected across this line y equals x, because now all the x's that were, all the numbers that were x's are now y's, and all the numbers that were y's are now x's. This one's going to look just like log base 2. It'll be the reflection of y equals 3.5 to the x over the line y equals x. That's one way you can think about it. And also you could just graph it, pick a couple of points, and remember that it looks just like the graph we just did. It's going to go through the point 1, 0 instead of 0, 1. And for me, it just is more comfortable to change that logarithmic form to exponential form. So base to the power equals number. So we've got x equals 3.5 to the y, so x and y. So again, when you put in 0 for y now, you get 1 for x. And if you put in 1 for y, you get 3.5 for x, and so on. So you get the point 1, 0 and the point 3.51, and you could put in more values, but you already know what the shape of the graph is, and it doesn't have to be exact. It's a sketch. So it looks just like the graph we did before, except that the points are slightly, it's slightly stretched. Instead of going through 2, 1, it goes through 3.51. It still approaches the y-axis. As your y value gets very big negatively, as it goes down, down, down into the negatives, your x is getting very close to 0, but it can never be 0 because it doesn't matter what you raise 3.5 to, it will never equal 0. But 3.5 to a very big negative number is going to be a tiny, tiny number very close to 0. So the graph is approaching that y-axis. The y-axis is an asymptote for this graph. Okay, so here's some more problems on these abstract coefficients where you're solving for x and y just using letters and getting a formula to solve for x and y. So before you were just solving for x and y with letters, now you're going to solve for x and y with letters, and then you're going to use your formula that you get to solve for x and y in an actual equation that has real number coefficients or integer coefficients in this case. So the first thing you would do is you would use elimination to, you want to write a formula for x, and so you want to eliminate the y's, and so you would multiply the first equation by b sub 2 and the second equation by negative b sub 1. And if you do that, you are going to get a sub 1 b sub 2 x plus b sub 1 b sub 2 y is equal to b sub 2 c sub 1. And then for the second equation, if you multiply that by negative b sub 1, you're going to get negative a sub 2 b sub 1x plus negative b sub 1 b sub 2y equals negative b sub 1 c sub 2. And when you add those two equations together, the y's are going to cancel, and you will end up with a sub 1 b sub 2x minus a sub 2 b sub 1x equals b sub 2 c sub 1 minus b sub 1 c sub 2. And then you're going to divide that, you're going to factor out that x, and then you're going to divide both sides by that factor. So you're going to have b sub 2 c sub 1 minus b sub 1 c sub 2 over a sub 1 b sub 2 minus a sub 2 b sub 1. So you now have a formula for x, and you can go ahead and look at this equation we have now, 3x plus 2y equals 8, and 4x plus 5y equals 3, and you can figure out what a, b, and c are and put them into that formula to solve for x. So your a sub 1 is 3, the first coefficient, and your b sub 1 is 2, the coefficient on y, and your c sub 1 is 8, the constant in the first equation. Second equation, you've got your a sub 2 is 4, your b sub 2 is 5, and your c sub 2 is 3. So you're going to just take these numbers and put them into the formula you created. So x would be b sub 2 c sub 1, so that's 5 times 8, minus b sub 1 c sub 2, so that's 2 times 3, and then over a sub 1 b sub 2, that's going to be 3 times 5, and then minus a sub 2 b sub 1, so that's going to be 4 times 2. And if you multiply that all out, you're going to have 40 minus 6 over 15 minus 8, and so that is going to give you 34 over 7. Okay, so now we're going to use this to solve for y in an equation. So if we want to solve for y in this abstract system of equations, we will need to make the x's go away. So we will multiply the first equation by a sub 2 and the second equation by negative a sub 1. And so we will get a sub 1 a sub 2 x plus a sub 2 b sub 1 y is equal to a sub 2 c sub 1. And then for the second equation, we'll get negative a sub 1 a sub 2 x plus negative a sub 1 b sub 2 y equals negative a sub 1 c sub 2. And then we'll add the two equations together, and the x's will cancel, and we'll end up with a sub 2 b sub 1 y minus a sub 1 b sub 2 y is equal to a sub 2 c sub 1 minus a sub 1 c sub 2. To factor out the y, and then divide both sides. And you get y equals a sub 2 c sub 1 minus a sub 1 c sub 2 over a sub 2 b sub 1 minus a sub 1 b sub 2. And so now you can look at your equations up here with the real number coefficients, and you can figure out what your a1, a2, and so on are. So a sub 1 is 3, b sub 1 is 2, c sub 1 is 8, and then a sub 2 is 4, b sub 2 is 5, and c sub 2 is 3. Plug it all in, multiply it out, and you end up that y is negative 23 over 7.